Okay, hello Cloud Gurus and welcome to this lecture. So we are going to summarize everything that we've learnt in the high availability architecture. You've done really well to get through this section of the course. It is one of the most challenging. The only one that's more challenging is the serverless one, which is coming up. So what did we learn in this section of the course? Well, we learned there's three different types of load balancers. If you remember the cars example, so we have our application load balancers. They're layer 7 aware, and they're pretty much what you typically would want to use in production because they can make intelligent routing decisions. We then have our network load balancers. So just remember the Tesla Roadster. This is where you need extreme performance or perhaps a static IP address. Network load balancers are not application layer 7 aware. They only go up to layer 4. We then have our classic load balancers. These are basically where you want to keep costs under control. You don't need intelligent routing and you just want to keep your costs down. So we have the three different types of load balancers. Remember what they are and their use cases going into the exam. Now in the lab, when we were rebooting our RDS instance, it caused our site to go down and we got a 504 error. And this means that the gateway has timed out. So our whole web application is not working. And it could either be our web servers or our database servers. In our lab, it was our database server that stopped working. So just remember that a 504 error means that the gateway is timed out and you need to figure out what's going on with the application. Is this the web server layer, the application layer if you've got one, or database server layer? Moving on, we learnt about with classic load balancers, if you need the IPv4 of your end users, you need to look for the X forwarded 4 header. We then also learned that instances monitored by Elastic Load Balancers are always reported as either in service or out of service. And you can put health checks, which check the instance's health by talking to it. So we did that with the healthy.html file. And then load balancers always have their own DNS names. You are never given an IP address. And by that, I'm just talking about application load balancers as well as classic load balancers. You can get a static IP address for a network load balancer. I would recommend that you go and read the Elastic Load Balancers FAQ. I say in the slide for classic load balancers, I'd read the FAQ for all load balancers. You're going to get about 10 questions on your exam concerning load balancers, and a lot of them are just going to be scenario-based questions as to which one you should choose. You might get a question about gateway timeouts, so if you've got a 504 error, and you might get some questions on, using a classic load balancer, how you get a public IP address. Do you remember? It's using the X forwarded 4 header. And then if you want a deep dive on application load balancers, I appreciate we just went over it in a very sort of high level. We definitely have a deep dive course on the A Cloud Guru platform showing you how to create super intelligent routing decisions. We then went on to learn about advanced load balancer theory. So we looked at sticky sessions, which enable your users to stick to the same EC2 instance, and this can be really useful if you're storing information locally to that instance. We also looked at an exam scenario where essentially we weren't getting connections to another EC2 instance, and the way to enable that was to disable sticky sessions. So sticky sessions can come up in either sort of scenario. We then looked at cross-zone load balancing. This enables you to load balance your traffic across multiple availability zones. And we looked at a scenario where essentially we're having issues where traffic wasn't being routed to a particular instance in another availability zone, and that was because we didn't enable cross-zone load balancing. And then we looked at path patterns, and this allows you to direct traffic to different EC2 instances based on the URL contained in the request. And we looked at myurl.com was going to our web servers, whereas myurl.com was /images was going to our media-based servers, which were in a separate availability zone. And then we looked at CloudFormation. CloudFormation is a way of completely scripting your cloud environment. And then we also looked at Quick Start, which is a bunch of CloudFormation templates already built by AWS solutions architects, allowing you to create complex environments very quickly. And then finally, we looked at Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS cloud without having to worry about the infrastructure that runs those applications. You simply upload your application, and Elastic Beanstalk automatically handles the details of capacity provisioning, load balancing, scaling, and application health monitoring. And I used an example. Elastic Beanstalk really is aimed at developers who just want to get their stuff into the AWS cloud quickly. They don't want to have to go and learn something like CloudFormation. CloudFormation is way more powerful than Elastic Beanstalk, but again, then it takes an awful lot to learn it. If you do want to learn CloudFormation, of course, we have an advanced CloudFormation course on the A Cloud Guru platform. So that is it for this section of the course. In the next section of the course, we're going to look at applications on AWS. It's mostly going to be theory. We're not really going to go into a lot of labs on that because you don't need to. You just need to understand the theory in order for you to pass your exam. And then we're going to go on to the funnest part of the course, which is serverless, and then we're done. So you're almost at the end of the course, just 2 more sections to go. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.